Hello, this is the progress updates for my master's degree. My research topic is detecting the cyber attack using anomaly detection methods. So this progress updates will start with introduction and then come to the contribution. For the problem statement, this research is to detect the cyber attack in multivariate time series. Proposed methods is to build individual model to detect the cyber attack in battle data sets based on techniques of matrix profile, autoencoder, and boosting. Then we'll combine the individual model to give the integrated cyber attack detection system. Let's introduce the battle dataset. So battle is from the iTrust. This data set are collections of sensors reading containing simulated cyber attacks in water distribution system. This water distribution system it's called the it has the network as shown in the graph. And for the data set, there's 3 data sets, contains 1 year data, 6 months data, and 3 months data. In data set 1, it is all normal operations. So it doesn't in other words, it doesn't contain any attacks. While the other 2 data set has attacks. So for this data, for all 3 data sets, it has 43 variables, and we can categorize the variables into 7 categories. They are water level of tank, water level of wall, water level of flow, water flow of pump, status of wall, status of pump, inlet outlet pressure for wall and pumps. And each data set has take time, definitely, and also it has the attack flags. To better visualize each type of the sensors, we provide the sample plots. We can see the data has we can see the sub-obvious characteristics like the sub-periodic features for each time series. Coming to the literature review, we introduce what is time series and what is our layers, and then what is the anomaly detections. So time series can be divided into 2 classes, univariate and multivariate. And the characteristics of time series can be observed by converting the raw data to a derived data set by reducing the dimension like a PAA. So you can see the raw data is in blue color and the derived data set using the PAA is in the color of orange. And for the time series, we can decompose it. We can decompose them into different representations, and this decomposition can using additive model and also multiplication models. So I'll give an example of the additive model. You can see the time series, raw time series. After decompose it, we can get the trend, seasonality, and then the remainders, which is noise. So outliers in this research, of the anomaly detections we're doing is to pick up the outliers. Outliers are outstanding values that derive from other time series points, and we can categorize outliers into three categories. They are global outliers, which from global view, which, for example, right, certain value is super big, which is absolutely abnormal. Then the other is contextual outliers. Like for example, if like every day every hour we have like water consumption for family, then so based on their everyday hourly consumption, we can have like we can gain gain a range that every hour how these families consume water. So if I see in certain hour the water consumption for the family is higher than the my expect which is out of the expected range, then we can capture this abnormal behavior. And this is based on the contextuals of the water consumption. So we call it contextual outliers. The other is collective outliers. So if we have multiple time series, we are sure they are linked with each other. So when I see a slight uh, abnormal in one time series, and at the same point we see this slight abnormal in other time series, then we can collaborate them together to give an to say in this time period there is outliers. So this is called collective outliers. And then based on the labels, if based on if the model using labels or not, we can divide the anomaly detection into three types. They are supervised anomaly detection, semi-supervised anomaly detection, and unsupervised anomaly detection. For the unsupervised anomaly detection, so the model is not using any label for training data set. And for the semi-supervised anomaly detections, the model is using normal operations label and not using abnormal behaviors label in training data set. Why we have this type is because it's easy to get the normal operations, because most of time the time series are most of them the time series are normal behavior, like most of the time the device are running normal, right? So we don't have the it's rare to get the attacks, and so it's rare to have properly labeled abnormal behaviors. So so in the semi-supervised anomaly detections, we're using the labeled normal operations in training data set to train the model. And then supervised anomaly detection. So basically it had the normal, abnormal classes for training. And then the algorithms used for anomaly detections can be divided into 6 types. They are statistic measures, distance-based methods, clustering-based methods, classification-based methods, feature-based methods, and deep learning-based methods. And among each type, we are using technologies of Gaussian distribution, regression models, like for statistic based methods, like KNN in distance-based methods, and k-means in clustering, SVM and boosting in classification, and PCA in the feature-based methods. Also the autoencoder in deep learning-based methods. So among them, for the distance-based methods, right, is fast and is fast in computation, easy to interpret, and also easy to integrate with other model. And there is no need of additional assumptions. But the distance-based methods accuracy is highly depends on the quality of the data, and it might be slow if we are dealing with large data set. Also, those requires high memory and computation powers, as we need to load all the existing classes, label the classes to memory, and compare current dataset with all the labeled dataset. Then for the deep learning based methods, there's no need for feature extraction and easy to uncover the relations among unstructured data. And also it's not require well-labeled data and efficient to deliver as we pre-train the model. But for the deep learning, is a black box in how a neural network arrives at a particular solution, and the many parameters, hyperparameters to be fine-tuned to solve the overfitting. Also, there's no standard architecture. Then for the classification-based methods, so it's efficient to deliver as the results at the pre-train, the model is pre-trained. And also it's useful to classify the examples as normal and abnormal behavior. But classification-based method require proper labeled data set. So these three methods are chosen in our research after the evaluation. And among them, we are using the matrix profile technologies and adopted with the KN model to give the first anomaly detection model. Then we are using autoencoder method technologies to give the second model. And then we look into the boosting and use XG boosting like GBM and CatBoost to give the third model. So, here we want to introduce more about matrix profile, as we are using matrix profile combined with matrix profile in the distance-based model. You can see for the matrix profile, the first step is to define a length. So then after you define the length, you can take out the window and scan it, do a sliding window with a full data set, and then get the distance of individual comparison and get the minimum amount of the distance, which finally the minimum distance will be contributed for the distance of current window. to looking into the detailed example given, so I'm define the length as 4. Then when I want to compute the my second distance, then my current window will be x2 to x5. Then I scan it with the full data set, but skip the exclusion zone. Why we skip exclusion zone is because they have overlapping. So then, so firstly, we compare x2 to x5 with x5 to x8. Using the Euclid distance computations, we can get the distance d5 to, and then go to the x6 to x9. Using the computer Euclid distance, we can get the d6 to. Repeat this process, then we can get d7 to, d8 to, d9 to. Then take the minimum value, we can get 32, which is the distance which contribute to the second position of the matrix profile. So if it's a regular pattern, right? So it will be repeated in the time series. So when we do this matrix profile, we will find the very small distance because it's a regular pattern, right? Happen again and again. So when we using the slider window to scan, we can get a quite small distance, and this is called multi-phase. And if I'm abnormal, which will already happen in the same time series, and then when I compare my current window with the full data set, we'll get a quite large distance, which we call multi-discord. So when we having the model, we will do the result evaluation with the parameters below. And come to the distribution, come to the contributions. So the matrix profile, how is it being used in the model? So we can see from the workflow diagram. So in the training data set, we do the motif discovery as it has a label and no attack. So we have retrieved the motifs, then we get the normal operation pattern after that, and in the motif discovery stage, we can also get how the distance for normal operations. So my abnormal behavior should be, most of abnormal behavior should be greater than this normal operations distance. So this is the this is when we apply motif discovery to the actual data set, we get results like this. So you have the raw data, then we compute the matrix profile, then we have we can find the minimum. We can find the minimums in this matrix profile, which are which we can convert back to the raw data and find the motifs. After we got these training results, when come to the testing stage, we are retrieving the Discord. So this is the steps to get the Discord. We can find a quite big distance from the matrix profile, which are the possible Discord. So after we got all these possible Discord, we filter it by the distance threshold getting training data set and remove the regular pattern by comparing it with the normal operations. But meanwhile, in case we miss any detections for the possible Discord with the max distance in matrix profile, we do a further analysis. So we decompose this signal and then apply it to the similar model of this Discord discovery. For those who is be categorized as the Discord with the decomposite signal, we will also put as a candidate for the layers. So so after we got this possible or candidates for the outliers, we merge them as all of the sensors should be linked together as they are in the same network. And when there's when there is multiple sensors see abnormal in the same time periods or similar time periods, we're saying we are saying this is the outliers we want. So by this way, we have the detection results for the using our layer profile, using the matrix profile. We can see we except this part, we detect all the attacks, but the start time and end time is not very accurate. So we got a quite high accuracy, but not good precision. Then come to the autoencoder. So for this autoencoder, we're doing the hidden layer of 3 and compression factor of 3. Then we are getting a mode or results as shown on the slides. So for this model, we have quite accurate start time and end time for the attacks, but we are having a lot of many false alarm, which is irrelevant to the attack time. Also within the predictions, within the actual attacks, we also not predict all. So to solve these problems, we combine it with the matrix profile model to give a better detection model. So the results can be improved from this one to here. You can see the improvement in much improvement in this F1 score precision in the weak core. Then we implement the boosting measures. And in each boosting, we have these 3 results. So the plan for the next week will be still focused on this capturing these missing detections. We try the decompositions which can capture first part. Now we are looking into more methods to see if we are able to catch all. Then meanwhile, we want to add the neural network based algorithm methods and also combine the profile methods with the boostings. Meanwhile, we have these papers. We found the papers which using the vectorial data sets. We'll use it as the benchmark for us to evaluate the results. Yeah. That's all for today's update, progress updates.